Yeah, I have less free time, but luckily I still have free time for meetups. So once again, hi, my name is Bence Bagyinszki, and as an application architect at Ad Novum, I led the process of separating an existing web portal into multiple detached applications. Today I'm going to share these experiences with you. So we are going to go through these 5 steps to show you. Oops.
You guys didn't hear it, right? Did you hear it in the back? No. Okay, let's try this one. Ez melyik? Az marad, másik nincs rajta. Okay.
Okay.
Uno momento.
You do have to tap it to make sure it works. Yeah.
Norbi.
Okay, can you hear me now?
Yes.
Super. So, as I mentioned, we are going to go through these 5 steps, and I will talk about the actions we did, the mistakes we made, and the lessons we learned during these architectural refactoring. So, as the starting line, we had a simple single-page application, Angular, as Norbi mentioned. I'm mostly working with Angular applications, which had basically 3 main functionality. It had a registration wizard for the new users, a self-service portal when the users could manage their own profile, and an administrator part where they could supervise the users. Also, this single-page application was connected to a monolithic backend, and the whole story was behind a single sign-on solution. Then some new requirements arise. Namely, the customer wanted that these modules must be separately deployable, and they also wanted to have URL structure which reflects this kind of module separation. They wanted this because of the easier reverse proxy setup. They wanted to put these applications behind different reverse proxies in order to enforce different strengths of the authentication. And third, these modules must not contain any unrelated parts. That was important for them mainly because of security reasons. So, this is the new design that we reached at the end. We have separate applications for the registration wizard part, the self-service portal, and the single-page application. Both of them communicating with their own dedicated backend and not a common shared monolithic one. So how did we reach that? First of all, well, we started with the code separation. This is how our code base looked like after this split up. You can see that we have multiple workspaces. For the project borders, that basically means an Angular workspace. And in some cases, in the workspace, we have only applications. In some cases, we have only libraries. And there's the registration project where we had a separate application and the library as well. Angular provides a solution for creating libraries since version 6. And we decided to use this for the reusable parts, like the so-called common library, which is used by all projects, and the registration library, which is used by both the registration wizard and the self-service application. The reason that this is used by both of them is that we had screens which are available from during the registration, but the exactly same screens are used as part of the self-administration. So the projects were depending on each other. And these are simple, so the arrows are simple NPM dependencies. But we had a problem with that, namely that during development, it would have been a really huge overhead if we had to create a new version every time that we change something, for example, in the common library, and we want to just test it in, let's say, the administrator project. So for the local development, we used file dependencies. In NPM, it's quite easy to configure. We could reference them this way. And with the help of this, it became possible to test changes of the libraries without publishing a new version from them. And we could try out the result, run tests against the applications without publishing a new version from them. Of course, code is not everything. That I can tell you that was the easy part, because if you do a mistake, made a mistake during the code separation, then you will immediately recognize it. Your build will most probably fail. There are also other assets like shared styles and other assets like images, logos, that you had to ensure that available for all of these applications. So what we did is that we moved it to the common package, and we simply copied it over to the applications. It can be easily done and configured in the Angular JSON, and basically that's it. It was a bit more difficult in case of the translations. We wanted to separate them, but that means that for the translation JSON, we had a JSON file with more than 1,000 keys and values, and we had to one by one separate them which application they belong to. Well, I can tell you that this is not fun. But after this is done and these keys are prefixed according to the modules, then a simple ngx multi-HTTP loader can do the job. So with the help of that, you can easily use multiple translation files. The most difficult part in such cases is the inter-application navigation and the state synchronization. Because of this, we try to minimize the navigation between these applications. So as you can see, there's one place when you enter at the self-service application from the registration wizard at the end of the registration process. And since administrators are users as well, they can switch over from the administration application to the self-service application to manage their own data. These are the only places where we had inter-application navigation. But as I mentioned at the beginning, these applications are separately deployable. So how do the, let's say, the administrator application knows where to navigate when it wants to open the self-service application. And the answer is that during the initialization, it loads it from its own backend. Okay, but when does the own backend knows? This is read as a property from a property file, so it can be configured easily. That's the base route, and after the base route, the exact navigation will happen with the help of some state synchronization between the applications. That was necessary because based on these states, different endpoints were used for the navigation. So we used for this synchronization query parameters which are progressed by navigation guard and removed from the URL. So the process looked like that the guard read these values, set some values in the store, and based on that it decided on which page to show. Let's see the benefits and the not so good parts as well. So first of all, we managed to meet the requirements. That's quite good. The applications were separately buildable and deployable, and the code parts were completely isolated, except of course the common dependencies. These modules could be versioned separately, and the dependencies were managed per project base. It means that, for example, when we upgraded from Angular 7 to 8, we could and have to do this one by one for each project. That can be a benefit, and that can be a difficulty too. And now about the problems. Well, first of all, the build order had to be ensured. So, of course, the common parts had to be built first, and only after that the applications could use that. We also have frequent conflicts in the package log file because the library changed quite a lot, and integrity hash changed with that every time as well. And that means in the applications, the package log file changed as well. And as multiple developers worked on the same project, this caused a lot of conflicts. Another drawback was that we could not use ngserve anymore in case of the changes in the common part, because we used npm dependency, and that was not automatically reinstalled and read by ngserve when we changed something in the common libraries. And last, the full build time of the project became significantly longer. Altogether, the developer experience decreased because of these facts. So we started to analyze what causes the problems, mainly the longer build time. And we ended up that maybe the problem is that we use npm as managing the inter-module dependencies. So let's assume that we find the bug in the common library, and that affects the self-service project. And we fix it, and we would like to see if it really solved the problem. So first, we have to build the common library, then do an npm install for the new version in the registration library, then build the registration library itself, then npm install the new version from the common and the registration library in the self-service application, and last but not least, build the self-service application, and now we are ready to try it out. Well, that's a lot, right? Another factor was that these npm installs took 1 to 2 minutes. Of course, this depends on the configuration and whether we use caching, but still, it's time. Another thing is that because of these dependencies, we could not do this in parallel. We have to wait with the build with the npm install, and then do another build, do another install, do another build. Because of this, the development became more difficult. As I mentioned, we could not use ngserve anymore at all places. And yeah, the frequent changes of the library project caused the package log file to conflict. So we realized that that's the problem. And what do you do when the current solution has problems? Yeah, as Bear Grylls says, improvise, adapt, overcome. So our solution idea was that, okay, but we already have a project, namely the registration project, where we have one application and one library in the same workspace. So why don't we have all the applications and libraries in the same workspace? And then we can reference these dependencies in the tsconfig file via path aliases. The output could still be multiple application packages, and in that case, one npm install would be enough. Well, actually, because of the Angular framework, 99% of the dependencies are the exact same in case of all the applications anyway. So we tried it out, and we realized that, yeah, the requirements still met. That's a good thing. No package log JSON conflicts anymore, and the ngserve does work again. Sounds like a happy story, but we have drawbacks again, namely that the dependencies are managed together, meaning that what I mentioned, that we were able to separately upgrade, for example, the Angular version in one project and not for the whole application, is not true anymore. This means the applications are somewhat more strongly tied together. And a fun fact, the build time did not decrease. And that's mainly because we did not count with one thing, and that's the limitations of Gradle. I did not mention that, but for the whole build infrastructure, we use Gradle. And it manages quite well to run independent tasks in different projects parallelly, but it can only do this between projects. If you want to have, if you want to run Gradle tasks in the same projects parallelly, then you need special tasks for that. And our build plugin was not prepared for that. So that could be maybe a next step to improve that. As a conclusion, we managed to meet the requirements with this architectural refactoring. We ended up having a monorepo structure, but not real micro frontends. That's why the title is towards micro frontends and not micro frontends. The separation of the code was not the difficult part of the story. As I mentioned, the integration and inter-project navigation and the whole infrastructure around it was much more problematic. And yeah, we know that the current solution is not ideal. This is still one ad novum project that our trustworthy team develops with great passion to provide engineered results. And we are in the middle of the work, but I think we already gained some experience that worth to share with you. I hope you see the same and enjoyed this presentation. I have a question side, but maybe because of the tight schedule, it's better if you ask questions in person later. Thanks for you.